Okay, I guess we can start today's webinar that we have prepared for you guys. So, without no longer overdue, welcome everyone and thank you for joining us today. Uh, we are excited to talk about Microsoft Fabric IQ and how AI is transforming data work in your organization. During this session, we'll explore how AI powered capabilities can simplify analytics, improve productivity, and help teams get more value from their data. On the slide, you see right now there is short agenda for today's webinar. Of course, there is a Q&A session after the presentation. Of course, if you have any question, just use a chat, type your questions, and we'll answer to that questions in the Q&A session. Hello, Patrick. Hello. It's nice to have you here. Okay, guys. I'm Lucas, and I'm in Elite Mind. I lead Fabric Technology area. With me here today are my dear, very talented colleagues, Bartłomiej and Mateusz. You see that there is a dark background uh, in the hours in the slide. So, but it doesn't mean that it'll be all dark. It will be very bright webinar for you. So, guys, please say few words about you.
Okay, so hello, I'm Bartek. And as stated, I'm a senior data platform engineer in EliteMind. Like my main area of interest is the backend, so ETL processes, transformations, and everything that happens in the background that makes things work. And I'm already working like for the 2 years in Fabric projects, building data platform in Microsoft Fabric. So I have like two years experience that I can share with you. Thank you.
Hello
Thank you.
everyone. As I mentioned, Łukasz, I am Associate Data Engineer at EliteMind, specializing in designing and delivering secure and efficient data solutions using Microsoft Azure, Fabric, and Databricks. Today, I will introduce you to Fabric Data Agents, an exciting new feature in Microsoft Fabric ecosystem.
Thank you, guys. As you see, we are all technical guys today, so it will be actually technical webinar, but I hope that you learn a lot. Okay, I'll start with the short overview description what Microsoft currently is, because that state is changing. It's changing through time, and some time ago, not so long ago, the Microsoft introduced the IQ workload that we are talking about in this webinar. So, what is Microsoft Fabric? Microsoft Fabric is a analytics platform that supports end-to-end data workflows, including data ingestion, transformation, real-time stream processing, analytics, advanced analytics like machine learning, and reporting. It provides integrated experience such as data engineering, data factory, data science, real-time intelligence, uh, data warehouse and databases, lakehouses, which operate over a shared compute and storage model. I will tell you about it later. Fabric is delivered as a software as a service platform, which is really important. And it uses one lake as a centralized logical data lake for storing and accessing data across all workloads, but not only workloads, all organizations. In tandem with OneLake, the OneLake catalog provides a centralized experience for discovering, exploring, and governing data and analytics artifacts across the tenant. AI capabilities are built into the platform to assist with data preparation, analysis, and development tasks, reducing the need for manual service integration and enabling efficient analysis to large scale data. Uh, on the slide, at the top of the diagram, there are core Fabric workloads such as data factory, analytics, databases, real-time intelligence, IQ, and Power BI. Each workload provides specialized capabilities tailored to different analytics tasks. But all workloads operate within the same fabric environment, the same platform, the same tenant, and can share data and artifacts without duplication. Beneath these workloads is the Fabric platform layer, which provides shared services used constantly across the experiences. One lake is the centralized logical data lake for Fabric. All workloads store and access data through one lake, enabling zero copy access patterns and allowing data to remain in its original location while being reused across experiences or workloads, whatever you call it. All right. What is also really important in case of Microsoft Fabric as a platform, there is a Copilot, which provides AI assistance embedded directly within a Fabric workloads, all of them, to help with authoring, exploration, and routine development tasks while respecting tenant data and permission boundaries we set on, right? What is also important and what is also a part of the Fabric is the governance area. In that case, governance represents centralized administration and data governance, including permission, sensitivity labels, and auditing. These controls are applied automatically and inherited across Fabric items. Governance is powered by Microsoft Purview, which is built into the Fabric in some scope, right? Microsoft Fabric centralized governance and discovery capabilities within the OneLake catalog, which serves as a unified hub to find, explore, and secure and use the Fabric items you need and govern the data you own. What are the areas that basically build us the Fabric as a platform, as a unified end-to-end data platform? The first workload, the first workload, it's Power BI, because at the beginning there was only Power BI, and then Power BI became a part of Microsoft Fabric. So Power BI lets you connect to data sources, create interactive charts and dashboards, and share insights across your organization. This allows business owners access to all data in Fabric quickly and effectively, enabling better data focused decisions. Another one, another workload, another part of the Fabric are databases. Databases in Fabric are a developer-friendly transactional database such as Azure SQL database, which allows you to easily create operational database in Fabric. Using the mirroring capabilities that Fabric possesses, you can bring data from various systems together in one lake. You can continuously replicate your existing data estate directly in Fabric One Lake, including data from Azure SQL database, Azure Cosmos DB, Azure Databricks, Snowflake, Fabric SQL databases, and all of those things. Uh, of course, there are also warehouses and lake houses, but in that meaning that Microsoft provides us about the Fabric, it's a part of different workload. I'll tell you in a few minutes. Another workload is a data factory. You may be familiar with Data Factory because there is something called Azure Data Factory, and this Data Factory it's basically very similar tool like ADF. So what is it? Data Factory provides a modern data integration experience to ingest, prepare, and transform data from a rich set of data sources. It incorporates the simplicity of Power Query, and you can use more than 200. I mean, half year ago it was over 170. Right now it's like 200 native connectors to connect to data sources on premises and in the cloud. So data factory are basically pipelines and data flows. Another one is industry solutions, where Fabric provides industry-specific data solutions that address unique industry needs and challenges and include data management, analytics, and decision making. Another workload which is really interesting and popular right now, it's real-time intelligence. Real-time intelligence analyzes data as it arrives, such as IoT sensor readings, application logs, or website click streams. It enables the extraction of insight, visualization, and action on data in motion by handling data ingestion, transformation, storage, modeling, analytics, visualization, tracking, AI, and real-time actions. The real-time hub in real-time intelligence workload provides a wide variety of no-code connectors converging into a catalog of organizational data that is protected, governed, and integrated across Fabric. Another workload, another part of the Fabric is data engineering. At Fabric, data engineering provides Apache Spark for processing large datasets with notebooks and tools for writing and scheduling data transformation jobs. It enables you to create, manage, and optimize infrastructures for collecting, storing, processing, and analyzing vast data volumes. Fabric Spark's integration with Data Factory allows you to schedule and orchestrate notebooks and Spark definition jobs and save the data that you process through the layers like in Medallion, and that data is stored on the lakehouses or warehouses where the Delta Parquet as an open source format is a default. Fabric Data Science is another workload. Fabric Data Science enables you to build, deploy, and operational machine learning models from Fabric. It integrates with Azure Machine Learning to provide built-in experiment tracking and model registry. Data scientists can enrich organizational data with predictions, and business analysts can integrate those predictions into their BI reports. For example, allowing a shift from descriptive to predictive insights, right? Another workloads is Fabric Data Warehouse. So Fabric Data Warehouse provides industry-leading SQL performance and scale. It separates compute from storage, enabling independent scaling of both components. Additionally, it natively stores data in open Delta Lake format, like the lake houses in Microsoft Fabric. And the last but not least, the IQ workload, which is new workload for unifying business semantics across data, models, and systems. Microsoft Fabric IQ introduces a new ontology item for organizing your core business concept and to rule into a unified semantic layer. That ontology connects to one lake data and existing semantic models to create a live, structured, connected model of how your business operates and offer a managed label property graph that is AI ready. IQ powers consistent decisions, reusable metrics, and context-aware automation across the whole Fabric platform. Okay, so I guess that's it from my side about the Fabric. We will focus right now on Fabric ontology and then on data agent. So Bartek, please go on.
Okay, thank you, Łukasz, for this introduction. So, Fabric ontology is together with the data agent. It's a part of the Fabric IQ workload. Just to provide you like Microsoft context of this feature, it's still in public preview. It was released in last quarter of last year or previous year, so it's a pretty new feature. And everything I will show today reflects what is available today in this preview. And I will clearly separate what is available now from planned features that we will look at later. So, ontology, it's a layer that connects what we want to know with how the data is stored. So on one side, we have how business thinks about the data in terms of decisions, questions, and outcomes. And on the other side, we have the data storage. So it's any kind of storage that one lake accepts. So it may be a lake house, it may be warehouse, or it may be an event house for streaming data. And the ontology provides a semantic bridge between these two worlds, which exposes to the business the way how we think and how we name our data, because many organizations may call a data entity in a specific way, and ontology provides a layer where we are able to define how we map our data to the entities, what are the relationships between our tables, and so on. So there are a few capabilities of Fabric ontology. First of all, we have this low-code UI that Fabric provides that enables us to model the entities inside our ontology item. Next, we can bind our enterprise data to a shared semantic foundation, so we can define a link between our entities and the data which reside in tables. Second capability is the enabling us to use the existing semantic models to generate the ontology, to have a like starting point for our ontology creation, just to not start from scratch. Next, we have the graph representation of ontology, which is always created together with the ontology, which enables us to visualize our data and present it in the organization, but also to explore and query this data. And last but not least, we have our data agents, which is like this data agents feature. It overlaps slightly with the ontology, and it's one of the Fabric IQ features that utilize the ontology, but not only ontology, which will be also presented later. Okay, so there are four basic concepts about the Fabric ontology. First, it's entity type. So this is the analogy to our table. It's the reusable business concept defined once, which is independent of tables, but is mapped to a table. And it's standardized meaning, identifiers, properties, and rules. Next, we have an entity instance, which represents a concrete occurrence of that concept. So we should think of it like a row of a table. Next, we have a property, which is just a type fact about entity, which is derived and linked from a specific column, but can be named in any way we want, and has defined unit and quality rules. And last, we have the relationships, which are type, directional connections between the entities. And they are crucial because they utilize keys that we have defined on our data. Yes, so we can now move to the next slide. This is the graph model that I mentioned. It's created together with the ontology. And it allows us to display our entities and relationships between them in a form of nodes and edges. So both the nodes, they have our name defined by us just to be more like company specific and to provide business friendly convention. And also the edges, which describe the relation. They are both named for the purpose of business understanding, but also they are used by the Fabric data agent to transform the natural language that we use to talk to an agent to the low-level language that the agent uses to query the data. And together with the capabilities come some limitations, which we identified during testing this functionality. So first of all, the entity identifiers must align with the grain of the source data. This is especially important when an ontology is generated from a semantic model. So the semantic model needs to be well designed because the grain for an entity should be always the same. We can define only one key for an entity, and when we map other tables, one table to several other tables, we always need to use the same key. So that may be a limitation, and that may be an assumption maybe to think about our semantic model quality to make it easy to transform into ontology. Next is this entity type support only one single static data source. Probably this will be solved in future, but at this moment we can map only one static data source, but we can enrich the entity with multiple time series sources which come from event house. Now we have this capability that ontologies can be generated from semantic models, but this doesn't mean that there is a sync between ontology and semantic model because there is no live sync. These are two different worlds. So this, I know that this also will be a subject of change in future. And the last limitation is that the decimal data type is currently not supported. So this can be a limitation since the decimal types are often used for aggregations of our data. And the last slide in this section, it shows the planned features for Fabric ontology. As you can see, there are 6 features which are planned for this next quarter. So the ontology rules, the ontology MCP tools and endpoint, also the integration with operation agents, scaled configuration canvas, which provides some user experience enhancements in the ontology UI, and also enabling the public API for ontology item management. And last but not least, the automated ontology generation, which will probably mitigate some issues that we currently have with the generating the ontology from a semantic model. Okay, so with that context in mind, let's take a look how it looks in practice. Okay, so we are in our Fabric IQ workspace, and here I will show you how to create an ontology and work with an ontology in Microsoft Fabric. So first of all, there are 2 basic ways to create an ontology. First, it can be created as a new item, which enables us to create an ontology from scratch with manual definitions and data mappings. The second option is to use an existing semantic model as a template for the ontology and use an option of generating the ontology automatically from the semantic model. And I will show this option in this webinar. So first of all, we have a semantic model created. This is a direct lake semantic model. Why direct lake? Because it has the best capabilities when it comes to generating ontologies when compared to other semantic model types. So this semantic model is based on some lakehouse tables, which are forming a star schema consisting of 3 fact tables with store sales, store returns, and web sales. In the webinar, we'll use mostly this store sales and store returns. The relationships defined in the semantic model, they are being translated into entity type relationships in ontology. And also it's worth noting that columns which may appear in the ontology need to be visible. Okay, let's generate our ontology from this semantic model. I will type here a name, it's IQ, ONT, retail. Okay, now this is pretty straightforward and fast operation. It may take no longer than 1 minute. Also, it doesn't create a sync between ontology and semantic model, which is like a live connection. It's only a one-time job that enables ontology creation based on the semantic model definitions. But later there is only a connection between the entities in ontology and the lakehouse tables. Okay, so here we can see the entity types created from the lakehouse tables. So we have entity types, we have the relationships derived from the semantic model relationships. And for the purpose of this webinar, I will adjust and configure one of the entities. And then I will show you the fully configured ontology with all the entity types properly configured. So the store sales, let's start from the entity type name. The entity type name, it should provide a business-friendly definition of entity. So let's call it just sales transaction. And next, let's add the entity type key, because for the dimensions like item, we have the entity type key derived from the foreign key in semantic model. Here we need to put it manually. So we'll choose the columns from the composite key, which are the ticket number, the sold date, and the item. Next, we define the instance display name. This is the column from which the value would be used in displays, like in query results. So we'll choose ticket number for it. Next, we have properties. Properties are just mapped from the columns in data source. So here, as you can see, the names may be technical because they are depending just on how the lakehouse columns are named. And we can adjust those names. As an example, I will adjust the SS item SK. I will change it to just item ID. Okay, we can also delete a property if it's not needed. So this is the place where we can provide business meaningful column names when the lakehouse column names are too technical or not so business friendly. Next, in the bindings, we can see that the source table is properly mapped here. There can be only one static source mapped to an entity, but we can add time series data coming from a streaming data source if needed. And last but not least, the relations. So here the relations have been created with some generic names like store sales has customer. We will rename it to provide a better like a language model. So a sales transaction was made by customer. And in the source data, we need to assign the workspace, lakehouse, and tables. Yes, so we choose the table store sales. And here we need to map our entity type key properties to actual lakehouse columns. So this is also pretty straightforward because these names are almost unchanged. We change the item ID from the key column, but so we'll just find the key column here. So this is this one, and we also need to assign the foreign key from the sales transaction to the key in customer table. So we know that the foreign key is SS customer SK. Okay, so let's create this relationship. Okay, so the relationship is created. As I said before, I will show you the full ontology after all changes. But at this moment, I would like to show you the entity type overview because clicking on this button, it triggers the refresh of the graph model, which is underlying the ontology. So here, the setting up your ontology, it means that the graph model under this ontology is being refreshed for the first time. So let's take a look at fabric monitoring. Here we can see that this activity has been scheduled to start, and it is the graph model refresh. And on each change in the ontology, the graph model is being scheduled. So it always keeps up to date with the ontology. Okay, now let's take a look at the final ontology that we have. So our ontology looks like this with the needed entity type names and with the relationships named to provide more business meaningful definition. So as you can see here, this the sales transaction has applied promotion, has occurred on date, and has been made by customer, and has sold item and was made at store. So yes, now if we will take a look at the entity type overview here, we can see what's the relationship graph between the entity types. And this graph is also reflected in graph model, which is used for querying and which is used by the data agent. So now I will go to the graph model. So graph model is an object that is associated to the ontology, together with the lakehouse and SQL analytic endpoints. And we can just go into that model and see what's here. Here we have also a graphical representation of the ontology. So we have it in the form of the nodes and edges. And we have also this query engine. So we can use the query builder to execute queries. So as an example, I would like to show a query that would help us to identify a store in which an item was sold that was later returned by a customer. So let's start from the return transaction. You can take this return transaction here and create a relation to item that was returned. Now for that item, we are mapping the original sales transaction. And to this sales transaction, we are mapping a customer. Okay, so and we are also mapping this customer to the return transaction. And last thing, we need to map the store at which the sales transaction was made. Okay, so we have our graphical query here. And to narrow down the results, we will provide a filter on item and on customer. So let's look only for item with a specific ID. And also a customer with a specific ID. Okay, so now we can execute the query and wait for the results. Okay, so here we can see the results of the query. We need to adjust the names because here, as we can see, this item is showing everyday essentials. Let's change the display property to product name. Okay, it's pure with paint. Now let's take a look at the store name. The store name also should be adjusted. So we'll change the display property of the store to store name. Okay, and also the customer display property to last name. Okay, so we can see here that customer Perry made a transaction, sales transaction, and also a return transaction on the product that was originally bought in the Fairview TN store. And we can also show the same information in form of a card view. So we just have a list of columns and values. Or we can show it in the table view where we get just a JSON formatted result. This query can be also presented in a code editor, and it can be modified here. And in fact, the data agents, they translate the natural language in which we ask them questions to the graphical query language, which can be seen here. So that's why the ontology definitions are important, and because they are providing a link between our natural language and the query language in the backend. Okay, and I think that's all about ontology part of the webinar.
All right, thank you very much. Thank you
Thank
very
you,
much.
Bartek.
Thank you.
So before we dive in, here's important context. Ontology in Fabric integrates with Fabric data agents, allowing you to ask questions in natural language and receive answer granted in the ontology's definition and bindings. This means our ontology serves as the foundation for the agent intelligent responses. So what exactly are Fabric data agents? They are a new feature in the Microsoft Fabric ecosystem that enables organization to build their own conversational Q&A system powered by generative AI. The key point is that these intelligent assistants allow every employee in the organization, regardless of their technical skill level, to interact with data using natural language queries. You no longer need to know SQL, DAX. You simply ask a question as if you were talking a colleague. So let's go the next slide. Why should you use Fabric data agents? Let me highlight the key advantages. Democratization of data access. This is the biggest game changer. Data is no longer the domain of specialists only. Everyone in the company can explore data independently. Natural language interactions, no coding required. You simply ask and get an answer. It's like having a data expert always at your fingertips. Rapid deployment and configuration. Unlike traditional BI solution that can take weeks or months, data agents can be configured and launched much faster. Multi-source connectivity. The agent can pull data from lakehouse, warehouse, semantic model, KQL database, mirror database, all in one place. Enterprise grade security and control. We don't worry about security. Access control and governance are built in. And last, external system integration, ability to connect with other tools, for instance, Microsoft Teams or Microsoft Thunder. How do we Actually build and operate Fabric data agents. The process is relatively straightforward. Step 1, choose data sources. First, we select our data sources or ontology. This is where our previously discussed ontology comes into play. It defines the structure and context of our data. Step 2, configure queries. We map questions to appropriate SQL or DAX queries. This is where we define how the agent should interpret the different types of questions. Step 3, provide agents interaction instruction. We give the agents instruction and source definitions. We can add organization specific guidance, examples, event communication tone. Step 4, this is test and validate. This is very important stage. We test different scenarios, verify that answers are accurate and meet expectations. And last, step 5, publish. When everything works correctly, we publish the agent and make it available users. Okay, theory is one thing, but let's see, this is action. Let's now move to a demonstration where I will show you how Fabric Data Agents works in practice. Hello everyone, my name is Mateusz, and in today's session I will guide you through the practical aspects of creating data agents in the Microsoft Fabric environment. I will demonstrate step by step how to configure and implement a data agent that effectively supports business processes in an organization. Before we proceed to the demonstration, let me cover the prerequisites that must be met for the data agents to function correctly. Capacity, Fabric capacity at F2 level or higher, or Power BI Premium per capacity P1 or higher is required. Feature activation, data agents and AI features must be activated in the tenant by the Fabric portal administrator. Data sources, the data you want to work with must already exist in one of the supported sources: Lakehouse, Warehouse, Semantic Model, KQL database, Mirror database, or Ontology. And last, access permissions. The data agents operates exclusively on data to which the user has read permissions. The agent executes queries on behalf of the user, so appropriate data access is essential. It is important to emphasize that the data agent uh, has no write, update, or delete capabilities. This solution is completely secure and compliant with the access control policies in place within the organization. Let's now move to the agent creation process. The first step is logging into the Fabric portal and selecting the appropriate workspace. In my case, I have selected Microsoft Fabric IQ workspace. We click New Item and search for Data Agent to create a new agent. The first configuration element is the agent name. While this may seem trivial, it is worth providing a name that easily identifies the agent and reflects its purpose within the organization. Since our data agents will support collection processes, I am naming it Data Agent Retail. After clicking Create, a quick validation occurs and the agent is created. The first task after creating the agents is adding the data source we will be working with. We click Add a data source, which opens the OneLake catalog. Here we have access to all available data sources. In our case, the data is located in Ontology. And Lakehouse. After clicking add, the data source is validated and successfully added. After adding the data source, we see that our lakehouse and ontology appear on the left side, but in the case of lakehouse, no tables have been selected yet. We must manually select the tables that will be used by the agent. I would like to emphasize that it's worth selecting only those tables that actually contain useful information. This way we don't clutter the agent's knowledge and make it easier to find the specific information we'll be querying. However, I will mark all of them. The system allows adding up to 5 data sources in any configuration, for example, 2 lakehouses and 1 ontology. However, I would like to caution that the more data sources, the more difficult the agent orchestration becomes. Therefore, it is advisable to limit data sources exclusively to those that are crucial for our business use case. At this point, I would like to mention the concept of AI-ready data. It is crucial to ensure that the names of sources, tables, and columns are descriptive and precise, and that the data structure is clear and logical. If the data is not well organized, the agent will have difficulty navigating through the maze of relationships and information. At this moment, we have already added a data source, but our agent resembles an employee who has given access to data, but hasn't yet completed onboarding. It doesn't know what our business terms mean, which rules are important, or how to interpret query intentions. For the agent to receive the business knowledge, we need to provide instruction. The first is a global instruction for the agent itself, in which we describe the agent's purpose and scope of operation, prioritize regarding data sources, and definition of key business terms. Okay, now I will paste the instruction I prepare. In my instruction, I included the agent's operation goal, general behavior, for example, generating top 5 results in tables, data model to grant the agents in our source, business rules and prioritize, and guidelines for handling unexpected situation. This instruction helps the agent respond accurately and in line with business expectations, but it doesn't yet grant in the actual data. Now I will move on the instruction for the data source. We have 2 sections here. Data source description. I will paste the instruction. And data source description serves to present the context and characteristic of the source. We inform the agent what to expect from this data source and what information can be there. We don't delve into technicalities, but provide business context. And data source instruction, we define specific rules and logic for using the data source. In this section, we include description of available tables in the source, detailed schema of each table, relationship between table, and guideline for generating SQL queries. Thanks to this instruction, the agent receives business logic and knowledge about interpreting the intention of our queries, which translates into more accurate responses. The final configuration element is example queries. These are pairs of questions in natural language and their corresponding SQL queries. I am importing previously prepared examples. The system validates all queries against the data schema. We don't want to teach the agent incorrect patterns. After acceptance and validation, the examples are used by the agents to generate responses. I have added 4 examples. These are as the most frequently asked questions that were previously executed manually on the database multiple times. Why are these examples so important? They act as reference point for the agents. It is worth adding particularly difficult cases where the logic required to create a correct SQL query is complex. The agent might stumble in such cases even though the information is theoretically contained in the instruction. Is the case of ontology. We don't need to configure instruction because we did it when creating the ontology itself. So we now have a fully configured agent. Let's see how it works in practice. Let me ask the agent which customer bought the most quantity. Use source our ontology. As we can see, the agent analyze the data and identified the customer with the highest purchase quantity. Now let's test if the agent maintains context between queries. I will ask for more information without specifying which customer. Let's see if it remembers. Give me more details about this customer. Excellent. Even though I didn't specify the customer name or ID, the agent understood from the context that I am referring to the customer from the previous query. This demonstrates that the data agent maintains conversation context, making interactions much more natural and efficient. Now let's shift focus to product performance. I want the agents to work with our Lakehouse data source, show the products that generate the highest total revenue, present product name and total revenue, ranked by revenue, use source, our Lakehouse. Perfect. The agents correctly aggregate revenue data from our Lakehouse, identify the top performing products, and presented them in a clear ranked format. Notice that the agent returned 5 results. This is because in our agent instructions, we specified that it should always return the top 5 results by default. This gives us immediate insight into which products and driving our business without overwhelming us with too much data. Let's ask a more complex analytical question that requires the agents to combine multiple metrics. Which products generate high revenue but also have high returns? The agent analyzes both revenue and returns rates together. This insight is crucial for retail. It helps us identify products that appear profitable but may have quality or customer satisfaction issues. With this information, we can make better decisions about our product portfolio. As we have seen, our data agent handles various queries very efficiently and actively supports processes in the retail department. Thanks to proper configuration, detailed instruction, and example queries, we have created a tool that understands business context and delivers meaningful results. Thank you for your attention. After the demonstration, let's summarize the key takeaways about Fabric Data Agents. One, specialization is critical. The agents must be well defined and focus on specific areas. We can't expect one agent to be an expert on everything. Data alone is not enough. This is very important. It's not enough to just fit the data agent. It needs context, instruction, examples. Here again, our ontology lakehouse plays a crucial role. Simplify reporting workflows. Data agents significantly streamline reporting workflows. Instead of waiting for reports from the BI team, users can get answer independently. Built-in security and governance and security controls are foundational, not an add-on. We can rest assured the data is protected. Uh, and in a nutshell, Fabric Data Agents are the future of democratic data access in organization. Through integration with ontology and AI capabilities, we can transform how people in the company work with data. Great. We have reached the end of this presentation, so I will now hand over to Łukasz.
Thank you, guys. I think that was a beautiful, precious, precious, and yet unexplored piece of knowledge. So thank you very much. That was really entertaining. And just few really few words about the Elite Mind. We as Elite Mind. Elite Mind basically is a consulting company. We are focusing just on the data. A word. This word is of course huge word. So we are focusing on data, clouds, and AI. As you saw, uh, we basically we consult, we deliver, we support. So if you have any questions, do not hesitate to contact us. Uh, time, I'm sure. This is the Q&A session. So if you have any questions for us about today's subjects, do not hesitate to write those questions in our chat. All right, there is a first question. I'll read it aloud. So, have you already implemented Fabric IQ for any real client? If so, was it successful? Currently, the Fabric IQ was not implemented because it's like 2 months old, the workload. So it's pretty new. And in my opinion, uh, no one really knows about it. I mean, the people heard about it, but yeah, it's really fresh. Another question: Microsoft is working about making multiple task agents. I don't know that. Maybe Mateusz or Bartek knows something about it. But uh, I have no that knowledge.
Yes, Microsoft is actively working on building system that supports multiply task and multi-agent AI, allowing different agents to handle different and work together. Yeah.
Okay, next question. Are there any plans where Microsoft is going to show the multiple task agents?
So this is part of broaden vision in Microsoft AI strategy. Yeah.
Yeah, I mean for
Maybe
some specified
if
dates, I guess the Microsoft should be asked about it. Right now, there is no some specified information about the date where they are going
yeah.
to show the multiple task agents. But we know that they are working on it. Okay, there is the next question. Is there any auto data check solution to check if data provided for AI agent is enough, or is it missing some information in order for agent to work properly? Guys, do you have some knowledge about that subject in case of some any auto
Yeah,
data
yeah,
check solution?
exactly. These are ways to check whether your data is ready. Mm, First of all is the programmatic evaluation of the data agent. Microsoft offer a data agents evaluation feature via the Fabric Data Agents SDK that lets you programmatically test how well the agents responds to sample question against expected answer. Yeah, so this is a essential way to assess coverage and accuracy for your particular data set. Mm, the another idea is data quality and validation tools. Before you um, feed data into the agent, you can use data quality and validation tools that catch issues such as missing values and so on. Uh, for example, Data Wrangler helps you visually explore and fix nulls. And this part or AI-based data validation tools like solution like that automate uh, cleansing, schema checks, and so on. Yeah. Thank you.
And also, like this data agents, they by design force the data to be correct. For example, we have been testing this data agent with ontology. So if there was any issue with the ontology, there were validation errors which were coming from the ontology structure. It was not well defined with some wrongly mapped keys, for example. So this is the kind of of forcing the data which is used by agent to be properly configured. Yes, it's like a few layers of the data. But in case of lakehouse data, I think that at this moment there is no functionality that enables just a feedback about our data other than just answer from the agent that something is wrong with our data.
I'll give you 2 minutes to write your question in the chat. If there are no questions after 2 minutes, we can finish the webinar. All right, I think there are no more questions. If you have any and you would ask it about after the webinar, do not hesitate to contact us as Elite Mind, and we'll answer you to that question. So I guess we can finish today's webinar. Thank you all. Thank you guys. Thank you Mateusz. Thank you Bartłomiej. Thank you the marketing team for organizing such a beautiful webinar about really unexplored and fresh matter. And once again, thank you very much. Have a nice day. Follow us on LinkedIn. We are organizing a lot of cool webinars and events. So stay in touch. Thank you very much.
Thank you,
Have a nice day.
and see you next time.
Thank
Thank
you.
you.